And we'll have a shorter video for the last lesson in Chapter 5. Here we're looking again at some application problems, but in particular, we're going to work with a bit more of a step-by-step approach to handling some word problems here. So number one, we're going to start off, we will define our variables. Often a diagram will help, and whenever a diagram can help, it certainly helps to include it because that communicates your solution much more effectively. Next, we're going to write an equation. Writing this equation will let us algebraically reach a solution, and reaching this solution algebraically argues our position. It argues why. It makes someone who is reading our work, it makes them understand 100% how to reach a solution like this. It lets us allow the person who's reading it to understand our solution. Number three, we're going to rearrange the equation and simplify it if necessary. Often that means we're setting it up into standard form. We know we've been working in standard form a lot lately. Once it's in standard form, we can often work to either factor or use our quadratic formula in order to find a solution. And then we want to make sure we solve our equation using the appropriate method. That means that if we're able to factor it, we want to factor it because factoring, A, it's easier, and B, it gives us less opportunity to make a mistake, whereas using the quadratic formula is certainly a little bit more complicated. Though I'm hoping our skills are certainly feeling up to par at this point so that we could use the quadratic formula when we need to. Number five, we'll take a look at the solutions that we come up to from solving that equation, again, whether we use the quadratic formula or by factoring, and we'll look at the answers we came to. If these answers make sense within the context of the problem, we'll use them. If the answers don't make sense, like say we have a negative time or a negative position, then we'll reject those solutions, we'll consider those inadmissible, and we'll only use the acceptable solutions in our concluding statement. That's how we finish off a word problem. So we'll check it out here. Our first problem is a right triangle. So one leg of a right triangle is 1 centimeter longer than the other leg. So by legs, we mean these are the sides that are not the hypotenuse. The length of our hypotenuse is 9 centimeters greater than that of the shorter leg. Okay, so we have two legs. We'll call them A and B. And then a third side, that's our hypotenuse, that's length C. We know that we're working with side A. We'll call side A, let's call side B x plus 1. The length is x plus 1, and A, the side length, would be x. If we're doing this, we need to make sure we have our let statements, because all of a sudden we're using a variable in here that's not necessarily that doesn't have mathematical meaning to it, right? A, B, and C in a right triangle, those have meaning, but an x certainly doesn't. So we'll say let the shortest side length be represented by x. Fantastic. Then side length B is x plus 1, and side length C, we're told, is 9 centimeters greater than the shortest leg, so that equals x plus 9. Fantastic. Now, again, it is a right triangle. Since it's a right triangle, we need to have that symbol in there representing that. Now, we know from our buddy Pythagoras, we know from him that a squared plus b squared equals c squared. That's his theorem, right? The Pythagorean theorem tells us that the side lengths a and b, when they're squared, they equal the square of the side length c. Now, again, this is just for a right angle triangle. If that's the case, since that's the case, we can substitute in these values. So c equals x plus 9, a equals x, b equals x plus 1. We can substitute those in. So we can sub a equals x, b equals x plus 1, and c equals x plus 9 into, we'll call this equation 1, our Pythagorean theorem, into 1. So that will then look like x squared plus x plus 1 squared equals x plus 9 squared. Okay, fantastic. Now we've already, if we take a look at our solutions so far, we've already gone through a number of the requirements of the steps that we're expecting to follow, right? We defined our variables. We wrote an equation to model the solution. That was our Pythagorean theorem. We rearranged and simplified the equation. There we are. And well, actually, we're partway through that process right now. We know that we might need to have that in standard form. And of course, we included a diagram. Now, if we're putting this into standard form, we can do so. We know how to do that. We'll need to expand everywhere where we have a binomial squared. We'll need to expand that. I know this is, I know the pattern of a perfect square by this point, so I should be working with x squared plus 18x plus 81 on my right-hand side. And on my left-hand side, I'm working with x squared plus, and then this is from the brackets, x squared plus 2x plus 1. Fantastic. Now I can collect some like terms over here to get rid of my brackets. And really, I don't really need those brackets anymore. So I'm working with 2x squared plus 2x plus 1. And I can simplify this even further, right? Because I have, right now I almost have what looks like a standard form on both sides of the equation, but it's not standard form because one of the sides doesn't equal 0. So we'll need to set one of those sides equal to 0. We'll set the right-hand side equal to 0, meaning we're subtracting each of these terms from the left-hand side. So my left-hand side is 2x squared minus x squared. There, and I might play around with my colors right here. Minus x squared. And that's one that came from the other side. And then I have plus 2x minus 18x. So you're understanding why I'm setting it in this order when I subtract them on the left-hand side, because these are already organized with my like terms. So plus 1 and then minus 81. Fantastic. Leaving me with, once I collect my like terms, once I simplify it, then I'm working with here on the left-hand side, that's x squared minus 16x minus 80 equals 0. All of a sudden, I have standard form. We love standard form. We know how to solve problems when they're in standard form. Next, we need to we need to solve this equation using an appropriate method. So we ask ourselves, do we have to use our quadratic formula, or can we factor? Well, let's try it out. Let's try factoring it and see if it works. So if we're factoring it, we need to multiply the number negative 80. We need to add to negative 16. So we'll try it out. We'll find some factors of negative 80. And here I'm working with 1 and negative 80, 2, negative 40, 4, negative 20. And you know what? I think we may have found it. Let's start adding up our rows. I have negative 79. That's not it. Negative 38. That's not it. Negative 16. That was my goal, right? So I have two numbers that add up to negative 16 that multiply to negative 80. Fantastic. That's what we want to work with. That tells us that when we factor this, we're working with x plus 4 and x minus 20. Okay, now from here, we have factored it. Once we factored it, we know what to do, right? We factored it, meaning we set each of our factors equal to 0. So let's set x minus 20 equal to 0 over here, and x plus 4 equal to 0 over here. Let's rearrange. So once we rearrange, we isolate for x. We find that x equals negative 4 here on the left, and we find that x equals positive 20 here on the right. Fantastic. We have, sorry for the funny zooming here. I think my app isn't fully agreeing with everything I'm doing here. But we've solved it using the appropriate method. We did not have to use our quadratic formula, and that's ideal. And then next we're going to consider which values are possible. Well, let's remember what x represents. X represents the shortest side length. Is it possible for our shortest side length to be 20? And that'll be 20 centimeters? Yes, it is. What about negative 4? That does not seem reasonable. That's negative. A negative side length doesn't make any sense, so it's inadmissible. And so, therefore, sides A equals 20 centimeters. B, remember, side length B, geez, I'm sorry for the zooming. Side length B equals x plus 1, so that'll be 21 centimeters. And side length C, x plus 9, that's 29 centimeters. Fantastic. Now, note that what we used inside this solution, we included every single step along the way. Sometimes some of the steps you'll find are already done by the time you get there. Maybe when you're going through your own solution with a different problem, maybe it's already in standard form here. Okay, if it's already in standard form, then it's nice and easy for you. Maybe, rather than it being in standard form, maybe it's already in factored form. Man, if it's already in factored form, then you don't need to factor it yourself in order to find the solutions. You can just work from there. But either way, we're feeling pretty good about our work there. Now, the example 2 is actually, oops, it looks a little bit funny here. It should say h equals over here, not on the first line. But example 2 is actually the exact same, a very, very similar problem to that when we were working with a basketball in the previous video. So I'm not going to go through the solutions for A, B, and C. What I want you to do is I want you to use these to try and test your abilities to handle a question that's very similar to the last video. If you can do it on your own, that's great. If you need to refer to the last video, you can do so, but you should be able to handle a problem like this on your own.